There are different types of mass timber framing methods. To start, we have load-bearing walls. In load-bearing wall systems, the walls themselves bear the loads of the upper floors and roof. This system uses thick walls that often serve both structural and insulating functions. It can be used as a standalone system or in conjunction with columns for added support. Next up is the post and beam system. The post and beam system uses large wooden columns and beams to form a strong structure. This method is ideal for open floor plans because the beams carry the load of the upper floors and roof, eliminating the need for internal load-bearing walls. Because of this, internal walls could only be used for dividing spaces, instead of supporting the building. And finally, we have the post and plate system. The post and plate system is similar to the post and beam system, but it uses floors that are directly attached to columns, without additional support from beams. Now that we've covered the main types of mass timber framing methods, let's compare them side by side. To do that, we'll fill in this table together to give you a clear breakdown of the pros and cons of each method. Buildings constructed with load-bearing walls require a high volume of material, whereas post and beam constructions use a moderate amount, and post and plate methods use a low amount. The amount of material used directly determines a structure's overall weight, with more material resulting in a heavier structure. This weight, in turn, impacts foundational requirements, as lighter structures impose lower loads, allowing for less robust foundations. Load-bearing wall construction requires minimal labor skills due to its straightforward nature. In contrast, post and plate construction might demand additional training, while the post and beam method requires a high level of precision. All mass timber framing methods benefit from the use of prefabricated components, making them generally fast to construct. Among these, the post and plate method is the quickest, followed by the load-bearing wall method. The post and beam approach is the slowest because it involves more construction steps. Load-bearing walls offer superior load distribution by avoiding concentrated point loads. Both the post and beam and post and plate methods rely on columns, which create point loads at the bottom of each floor. However, the post and beam method distributes forces more effectively from the floor to the columns, whereas the post and plate method depends solely on the corners of the floor plates to carry the loads. Load-bearing walls, typically constructed with CLT, provide excellent shear resistance. In contrast, both post and beam and post and plate methods require additional measures such as bracing or moment-resistant connections to safely resist shear forces. Since these connections are easier to achieve with the post and beam method, it scores slightly higher in this criterion. Although the inherent span capabilities of floor plates are similar across methods, the maximum unsupported span varies considerably due to the way that loads are distributed. The post and plate method offers average spans. Load-bearing walls allow for longer spans, and the post and beam method achieves the largest spans, sometimes even spanning areas as large as entire swimming pools. Uniform ceiling heights are preferable because they enable efficient floor-to-floor design and simplify the installation of suspended ceilings. Among the methods discussed, only the post and beam approach results in non-uniform ceiling heights. This means that this method scores lower on this criteria. The ease of interior finishing differs among these construction methods. Buildings with load-bearing wall systems are easier to finish due to their flat surfaces. The post and plate method poses more challenges because of the presence of columns, while the post and beam method is the most complex to finish, given that it incorporates both columns and beams. When considering usable floor area, columns offer an advantage because they occupy less space than walls. In column-based designs, the number and size of the columns are critical factors, with the post and plate method typically requiring more columns than the post and beam method. With appropriately sized columns and beams, the post and beam approach can achieve exceptionally long spans while minimizing the space taken up by structural elements. In contrast, the post and plate method is less influenced by the dimensions of its columns, and even larger columns, for example 1 by 1 meter, do not significantly improve the span capabilities. The load-bearing wall method offers the least flexibility in floor plan design because the walls serve as structural elements that cannot be easily removed or reconfigured. In contrast, both the post and beam and post and plate methods allow for greater adaptability in the arrangement of internal walls, thereby enabling more flexible floor plans. In this video, we focused on the mass timber skeletons of buildings, though other construction methods such as traditional timber framing, hybrid systems, and composites also exist. In the coming weeks, we will explore each of the mentioned methods in more detail, examining variants and real-world examples. Ultimately, the best method depends on the specific needs of the project. Stay tuned as we explore these systems further in the coming weeks.
Stay informed, stay inspired. TimberTalk.